All right, so as we take a look, ladies and gentlemen, we're going to do 10-3. We're going to get through the first 3 examples today. We have 3 goals. We're going to find the equation of ellipse. We're going to graph these things. And then we're going to work with ellipses H and K. We'll do more of that tomorrow in examples 4 and 5. That's when these things start moving around. The ones I show you today is the vertex is going to stay at 0, 0. Okay? So by definition, we kind of showed you that little PowerPoint slide already. It says an ellipse is a collection of points in a plane whose sum of distances from 2 fixed points called the foci is a constant. So foci are situated on the inside right here and here. And a point on the graph, if you find this distance to that focus and that one and you add them up, that would be the same if you took another point and found the distance to that focus and that focus. They'd be the same. So no matter where that point is, if you take those 2 distances and add them up to the foci, they will be the same. So there we go. Well, we have 2 that we're going to look at. We have one where the major axis, which means it's stretched long ways, is the x-axis. And we have one where the major axis, or it's stretched up and down on the y-axis. Okay, if you look at these 2 formulas, these guys look very similar, right? Look at these 2 formulas. What do you guys notice? Yes?
Everything's the same except for the location of b squared and a squared.
There you go. So your a squared and b squared are a little bit different, right? So if you look, a squared is over here underneath the x's, and b squared is underneath the y's, where it's vice versa over here. Okay? Well, the relationship between a and b says a is greater than b. So that means, in layman's terms, a is the big guy, and b is the little guy. So if the big number is underneath the x, then it's going to be stretched left and right. And if the big number is underneath the y, right here, then it's going to be stretched up and down because the y-axis goes up and down. Okay? You'll also see that they have h and k's. That's kind of like when we did parabolas. We had the h and k value. Those were our vertexes. Well, now that's our center. So our center is h and k. The nice thing is, h is still always with x and k is still with y. And it's always opposite of what I see in parentheses. Make sure you flip that sign. And we have those 2 values. We have the a value. And the a value is from the center to the major vertex. So that's a. So from your center to your major vertex. Center, major vertex or vertices. And then the b value is from your center to your minor vertices. It's on their minor axis, so up and down in this case. The b value is underneath the y, so we go up and down that b value. So again, that's from the center to your minor vertex. So on this one, the a is underneath the y, so we go up and down a, and we go side to side b because b is underneath the x's. Okay. Last but not least is the c value. Now the c value has its own little formula here. You guys see that? The formulas are the same. A lot of people think it's Pythagorean theorem. It's not. It's actually the difference of a squared minus b squared. So if I want c, I use this formula. And c is from the center to your focus. So center to focus. And foci, guys, is just focus plural. So we don't say focuses, we say foci. All right, so our a values are center to our major vertices, our b values from our center to our minor, and then last but not least, your c value is the center to the foci. All right, any questions, y'all? Nice thing is, quiz or test, I give you guys these formulas, and then you just have to be able to use them. Okay, if you look at the front of your notes packet, you guys have all of these formulas in here. Okay, so if I look at my formula sheet, there they are right there. Okay, this is where you might want to go off to the side and say, hey, what's A, what's B, what's C, and which way are they stretched? So here we go. I take a look. Example number 1. Let me zoom in a little bit here. Let me get this all on here. So example 1, I've got x squared over 9 plus y squared over 25, and that equals 1. And the things on a quiz or test I'd want to know is what's the center. I'll have little blanks there for you. So what's my center?
0, 0.
Hang on. What's my vertex? And what's my foci? Those are what we got to find. For me to find those, I'll eventually need A, B, and the C value. All right, so far so good. All right, center, H and K. H is always with X, K is with Y. So if I take a look, this is H, this is K, but I don't see any parentheses there. I don't see any numbers there. So what do we have? I got 0, 0. So there's nothing there. So it's just 0, 0. So I'm going to go ahead and graph that guy. I'm going to put a little C there for center. You guys okay with that? The next thing I want to do is identify my A value, and that will tell me which way this thing is stretched. Remember, A is the big guy, right? So which one's A? Ryan, which one's A? What's the big one?
25.
There we go. So this is A squared, and this guy's B squared. So because the big number is underneath the Y, I know this thing is going stretched up and down. Okay. So I'll write this out for notes, but you don't need to do this. Like on a quiz or test, I don't need to see this work. A squared is 25, so if I square root that, A's got to be what? 5. Now technically it's plus or minus 5, but because it's a distance, we just call it positive 5. Okay? So it's underneath the y's. That's what I go up and down. I go up 1, 2, 3, 4, 5. Mark it with a V. 1, 2, 3, 4, 5. Mark it with a V. Those are the corner points 0, comma, plus or minus 5. Do the same thing for B. What do you guys get for B?
3.
You guys get 3. And again, that goes back to this idea. Take B squared. I'll show the work here for notes. B squared is equal to 9, so I square root it. So that's how we get 3. It's underneath the X, so I'm going to go left and right 3. 1, 2, 3. 1, 2, 3. So far, so good. Now, this is a elliptical shape, so this thing should be curved. In the past, I've gotten diamonds. These are not diamonds. All right? So go ahead and make an elliptical shape, which is a curved, elongated circle. Do your best. Your graph might not be as pretty as mine, but do your best. Not all of you guys had paintings go around the state of Illinois in an art show like I did. It's kind of a big deal in the art world. I'm just kidding. Actually, though, I did have a stadium go around the state of Illinois in an art show. Do you believe me? What do you think? Do you think I'm talented enough to have a painting go around the state of Illinois?
Just
You think so? Okay. I can bring in proof. You guys don't believe me.
I think you should demonstrate on the board.
Oh. Demonstrate? Well, I need my paint. It was a painting. I don't have any paint. A paint off?
Yeah, Kevin's nice at painting. Yeah, Kevin.
Kev's got some painting skills?
Yeah.
Oh. Well, paint off later. All right, let's focus here. Sorry, guys. I'll bring it. How about my newspaper article? You can see my painting, newspaper article. You'll be impressed, I promise. Or not. I don't know. Or maybe I just made that up just for fun. Now, I need the C value. The C is for my foci. Do we have a formula for that?
A squared.
A squared
C squared minus B squared equals C.
minus B squared equals C squared, or C squared equals A squared minus B squared. So either one of those will work. So I'll write that here in pink. A squared minus B squared. Okay. So as we take a look, common mistakes, people grab 5 and 3 and use those. And make sure you're using these guys back at the originals. A squared and B squared is 25 and 9. So take the big guy minus the little guy. So we get C squared equals what, 16? Then we can square root that guy. And we should get C is 4. Okay. Now again, these are our foci. Our foci should be in our bowl here. Okay. So I wouldn't go left and right 4, because if I went left or right, I would take the foci outside of the bowl. That'd be silly, right? So we count up and down 4 from our center. So down 4, up 4. There we go. There's my foci. So I gave you guys that silly analogy before of the, with parabolas, we had the directrix. We had our parabola, which is like the breakfast bowl, and in our breakfast bowl is our focus, right? Our Fruit Loops, well, same idea. Well, now we're looking down at our breakfast bowl, and in our bowl is our Fruit Loops, right? Gives you a different overhead view of our breakfast bowl. Doesn't that make sense? Okay. Don't put your foci on the outside. I've seen that before. Okay. Your major axis is the y-axis with your major vertices, and that foci belong on there. So foci, we went up and down 4. That's 0, comma, plus or minus 4. Guys have any questions with example 1? We okay? All right, let's move on to number 2 then. Here we go. So they give me this equation. I've got x squared plus 4y squared equals 16. Now the problem is I want this to look like this. I always want it equal to 1. In this case, it's equal to 16. So what can I do with that 16? How do I move it? You could try subtracting, but that doesn't give us 1, though. So instead of subtracting, try dividing it over. So yes, very good. So we're going to divide everything by 16. And this gives me x squared over 16. 4/16, guys, is 1/4, or y squared over 4. That's how I'd write it. And then 16 divided by 16 is that 1. Okay. All right, so again, we're going to want our center. We're going to want our vertices and our foci. Quiz or test, I'll have those blanks for you. So this is the guy we're looking at. Any questions how I came up with that equation? H and K. Katie, what's H and K? You don't see anything up there. Yep, so what are those guys? You don't see numbers. Yep, so this is H, this is K. There's nothing up there, so 0, 0. Perfect. All right, so 0, 0. I'll put that guy right there. Then I want to identify the A value, which helps me identify which way this thing's stretched. All right, which way is this thing going? What do we got? Where's the A value? Dig? Yeah, so the big guy's right here, right? That's A squared. This is B squared. So because A squared is underneath the x's, it's going side to side. So again, if you need to, A squared is equal to 16, square root it. I usually just write, I do that in my head, and you can too. I just write 4. Again, because it's underneath the x's, that's what I go side to side. So nice job, Dig. 1, 2, 3, 4. There's one vertex. 1, 2, 3, 4. There's the other one. B. What's B? What do you got? Nick S., what do you got? Stephen?
2.
2. Boom. Again, if you need to, set B squared equal to 4, and then square root it, and we get 2. So up and down 2, up and down 2. So I've got my center, my major vertices, my minor vertices, and now I'll make a nice, pretty ellipse. Okay. Again, not diamonds, make it circular. Nice and pretty. And those vertices, what we went left and right 4, so that's plus or minus 4, 0. So far, so good. Last thing I need is my C value. I need my focus, right? So we go off to the side and we take the big guy minus the little guy. So I'll write that up here. C squared is equal to A squared minus B squared. 16 minus 4, that's 12. Right? Well, we square root that guy. Now, if you give me the square root of 12, it's not terrible, but I will take a half a point off. I do want simplified radicals here. So break this guy down. 12 is 4 and 3. The square root of 4 is 2. So that's why it's 2 and 2. So we end up with our C value is 2, and then this 3 is left on the inside. So pairs come outside because the square root of 4 is 2. The square root of 3 stays the square root of 3. It leaves it in the inside. We still need to graph that, so it is nice to know what that decimal is. So again, I've got the square root of 9. I got the square root of 16. The square root of 9 is 3. The square root of 16 is 4. Square root of 12 is somewhere in between, right? Yeah, so what do we get? 3.46. So if you need to look on your calc, 3.46. So I'm going to go about 3.46 boxes left and right, which is pretty stinking close, right? Pretty stinking close to the vertex. So how do I write that? Just plus or minus 2 root 3, comma 0. We went left and right 2 root 3, which is about 3.46. If you gave me the decimal plus or minus 3.46, or if you gave me plus or minus square root of 12, I'll probably just take a half a point off. I don't make a big deal about it, but I always say I want simplified radicals. Okay. Woo! Any questions? So not too bad. Give me a thumb. Where are we at? Thumb? Thumb, thumb, thumb. Any questions if you're here? Any questions? All right, let's finish up. We got about 10 plus minutes, or about 10 minutes or so. So let's giddy up. Last but not least, example 3. Sometimes they just give you information, and they want you to graph and then come up with the equation. So as I take a look, first thing I do is graph it. I got a center, 0, 0. And with that information, if I'm using my formula here, it's always equal to 1. And I don't know if it's a squared, b squared, or b squared, a squared, so I'm just going to put question marks here. I don't know what those are. But right now, if I have my center, who do I know? I know my h and k value. So if I plug that in, x minus 0 is x squared. Y minus 0 is y squared. Equals 1. Now I use this other information so I can pick out the a value, the b value, and the c value. So I can graph and come up with the equation. All right, my focus is negative 1, 0. So right there, there's the focus. Well, if I know that one's at negative 1, 0, then I should know where the other one is. Where is it?
1, 0.
1, 0. So, and that's because I know either A, B, or C. Who do I know? What is the definition from center to your focus? Is that A, B, or C? Center to your focus. That's your C value, right? C for Cam. Cam got that one, right? So C is 1. Any questions on how we got that one? Now we graph the vertex. The vertex is 3, 0, so I'm going to count over 1, 2, 3. And over 1, 2, 3 to the left, and negative 3, 0. So now I have my 2 vertices graphed, and now I should know A or B. I know A. Why do I know A?
Because the foci is on the longer side.
All right, so your foci and your vertices are on the same. These are going left to right. So then the a has to be here, the a squared. So a squared or 3 squared is 9. That goes there. So that means this guy's b squared. Again, the reason why I know the a goes underneath the x's is because we're going left and right for our vertices. That's our major axis. X-axis goes left and right. We're going left to right to plot those points, so I know it's underneath the x's. The problem is I don't know what b is. I know it's underneath the y's. I just don't know what it is. But we have a formula for that. Okay? What formula do we have for b? What do we got? Yep. Yeah, find the difference between a and c. So c squared equals a squared minus b squared is the formula I'm thinking. Okay. Again, I'm throwing in a lot of work here, so you guys can see what I'm doing. I'm plugging in c and a. 1 squared is 1. 3 squared is 9er minus b squared. And then we can subtract this 9 over here. And I'm running out of room, so I'm going to write up here, I've got negative 8 equals negative b squared. And if I divide by a negative, that's b squared equals 8. So b squared is this guy right here. So I have my equation. The last thing I'd want to do is finish up graphing this thing. So again, square root this guy. Break this guy down. 4 and 2, 2 and 2. I got a pair of 2's. The square root of 4 is 2. And then, this 2 is left on the inside. Again, the square root of 8 is 2.8-ish, I think, approximately. It's really close to the square root of 9, which is 3, but it's just not quite. So I'm going to go up 1, 2.8-ish, down 1, 2.8-ish. And now I'm going to make my ellipse here. Not my best, but that's not too bad. Now, if you look at this graph, it looks pretty darn similar to what? Looks like a circle, doesn't it? Now, the reason why it looks like a circle is because of these guys. These are pretty darn close to each other. So if you ever run into it where these two numbers are the same, that means you're going up and down, left and right the same amount, which means it's a circle. Okay. All right, do you guys have any questions? We'll see you again.
See you, Mr. Gotsch.
Yep. Any questions for me, y'all? Because I'm going to stop it right there. All right, ladies and gentlemen, we'll finish up examples 4 and 5 tomorrow.